Our guest today doesn't stop at finding security bugs. He finds thousands of them at once and tries to fix them. We'll introduce the three solutions that powered this massive fix: CodeQL, GitHub's code security code query language that finds security vulnerability patterns at scale, and OpenRewrite, a style preserving refactoring tool used at Netflix that makes the changes that these problems you found, and a custom built bot for generating these thousands of pull requests. So the links to everything we'll cover today will be added to the description box below right after the stream.
Hello, everyone, and welcome to the OWASP DevSlop show. Today's guest is Jonathan Lightshoe. He's a software engineer and security researcher. His research focuses on open source software, build infrastructure, and software supply chain security. He's best known for his July 2019 bombshell Zoom O-Day vulnerability disclosure. He's also championed an industry-wide initiative to get all major artifact servers in the JVM ecosystem to formally decommission the support of HTTP in favor of HTTPS only. In his free time, he contributes to open source security by finding and reporting security vulnerabilities to popular OSS projects. He is the first Dan Kaminsky Fellow, and to date has the most GitHub security advisory credits to his name of any open source software contributor on GitHub. Welcome, Jonathan.
Thank you very much. I'm happy to be here. I also want to introduce to the stream Jonathan Schneider. He is the CEO of Modern and the creator of OpenRewrite, which is the tool that is used to do this, massive amount of the rewriting of the source code in a way that is style preserving. So, yeah.
Thanks. Happy to be here.
Yeah. So let's dive right in. So this talk will cover creating thousands of pull requests to fix open source security vulnerabilities at scale, and the story around that and how it happened and how it works. So the introduction to me, the introduction was already really spectacular, but I just want to touch on the Dan Kaminsky Fellowship. I am sponsored by the Dan Kaminsky Fellowship. Dan Kaminsky was a famous security researcher who sadly passed away last year. He was very young, he was 42, I believe. And he had this drive, he went out and fixed these widespread security vulnerabilities. He's famous for a vulnerability in DNS and that he fixed silently. And it would have, been really terrible if it had not been fixed quietly. But he, did a lot of this work, and he was really passionate about fixing security vulnerabilities and doing it for the betterment of open source. And in his memory, his company, which he was a co-founder of, created the Dan Kaminsky Fellowship to sponsor an individual to go do widespread security research and, or fix things in open source. And I was, awarded that fellowship, and I'm humbled and honored to be in that situation. So I'm going to be doing more of this work over the course of the next year, thanks to that. So
Awesome. And congratulations.
Yeah, congratulations.
Thank you very much. Okay, so conflict of interest disclosure really quickly. I'm sponsored by GitHub. They gave me a free instance of CodeQL. They, and they're not financial, but they did give me a free instance of CodeQL to use for my own research and for private projects. It's open source for free project. It's free for open source projects and for open source research, but this lets me do it against closed source projects potentially. And then I'm also GitHub star. So just making that, putting that out there ahead of time. So this is a tale of two widespread security vulnerabilities. There are other widespread security vulnerabilities, but this tale is particularly about these two. So the first one is the JVM ecosystem's use of HTTP. And this was an industry-wide supply chain vulnerability. And we'll dive into that a little bit more. And then there was also this vulnerability that I discovered in a code generator called JHipster. JHipster is used as a tool to generate a a basic project. If you need to build a Spring MVC application or some other simple, like I need a web service, but I need it in Java. JHipster is a great kind of bootstrapping tool to get you a basic project structure up from the ground. And I found that the code that was being generated by JHipster had a vulnerability in it. So let's start with the first one, which is JVM ecosystem use of HTTP. So why is HTTP, the use of HTTP? So at a high level, this vulnerability was build tool. People are using build tools like Maven or Gradle or SBT for Scala. These build tools that are used to build your source control, which build tools, if you're familiar with other ecosystems, this would be like the equivalent of NPM for JavaScript, pip for Python. But in the Java ecosystem, we have Maven and Gradle are the two largest build tools. And in your build tools, you can say that I declare that I depend upon components, artifacts, libraries from repositories. And if you are declaring that you're depending upon those things explicitly, you can specify a protocol. And what I found was that very common, there was the use of HTTP instead of HTTPS. And this is a vulnerability because between your build tool and the artifact host, if you're using HTTP, there's nothing guaranteeing that you don't have a man in the middle intercepting your downloading of the jar file or whatever other source code or build artifact you're using, and isn't modifying it. And if they're modifying it in flight, they can inject additional malicious code into that and be running their own malicious code.
And just on that, how did that, like, what's the origin story of why HTTP was chosen? It was just like the default option for years and years and years, and just sort of persisted.
Yeah, so we'll get into that. But I think that I have so the reason behind that was back in 2014, Max Wietzman, who is pictured here, wrote up an article called How to Take Over the Computer of Any Java JVM Developer. And this was just on the coattails of the disclosure done by Snowden of kind of what governments around the world were doing to intercept traffic. And he made it clear to everybody that Sonatype, which runs Maven Central, which is the biggest, most commonly used artifact server in the industry, was only letting you use HTTPS to resolve your dependencies if you were donating to them. And so that was back in 2014. So Max Wietzman wrote up this article and held their feet to the fire and said, hey, why is this the thing? And it gained a bunch of notoriety on, Hacker News and stuff like that. And Sonatype fixed this. They added support for HTTPS back in 2014. And so I did my research back in 2019, and it had been, for 5 years, and I was still finding that this was a very common security vulnerability across the industry. And I was curious as to why. And so this originally started with this little bit of code that I found in my project. I was working for a company, and I found this, and actually I had written this line of code, and I was like, where did I find this? And I found that I'd copied and pasted this little bit of code from an open source project that I was depending upon. And so I was curious, okay, why is this present? And I found that source code, and I reported it to those maintainers, but I was curious what else, where other places this vulnerability potentially existed. So let's look at some quick examples of this vulnerability. In Gradle, this vulnerability may look like in your build script block. Can you see my mouse?
Yeah.
Okay. So in your build script block, this in Gradle declares that you're depending upon these dependencies for your entire build, which is like plugins. Like, so for Maven has plugins, Gradle has plugins. Those are not things that are actually like part of the source code that you release, but these are things that like compile your code or do modifications to your code. Here, these are dependencies that you're using as part of your published release. And then this is where you're uploading those dependencies is when you're releasing your software. And so if you're using HTTP in any of these places, you have a potential security vulnerability. Here in particular, you're uploading these dependencies. You're uploading what you're releasing. And in this case, you're uploading it. You're also leaking the username and password of that artifact as you're doing the upload. This is the same sort of component what it would look like in Maven, but it's a little bit reversed. The repositories, these are the dependencies that you use at the input to the compiler and load it on the class path for tests. This is where this is for uploading Just this when you're distributing, when you're running either Maven publish, and these are repositories declared for your plugins, similarly to the plugins for Gradle. So who is vulnerable to this? I did a lot of research and spent a lot of time looking at this vulnerability. And JetBrains, Eclipse Foundation, Gradle, Red Hat, Kotlin, Spring, Jenkins, Groovy, all of these projects had this vulnerability. Who else was vulnerable? Oracle, National Security Agency, LinkedIn, Stripe. I found this in a lot of places. I reached out to Maven Central. Give me half a second. Which is run by Sonatype, and they inspected their traffic for a month. And they said they figured out that 25% of their traffic was still using HTTP to resolve their dependencies when I disclosed this to them. So 25% of the industry's resolution of dependencies was using HTTP instead of HTTPS. So how can this be fixed? So I put forward a proposal on January 15th, 2020 to work with all these major artifact servers, Maven Central, JCenter, Spring, Gradle, and get us all collectively to stop supporting the release of or stop supporting the use of HTTP in this artifact server. So we all collaborated together, and on that date we shut off the use of the support of HTTP to resolve dependencies. It broke a lot of builds, but it fixed this glaring hole. The reason that we didn't all collectively decide to redirect traffic from HTTP to HTTPS was because if you have a redirect, it still leaves during that initial connection, it still leaves you vulnerable. The best way, and plus people would not have known they were vulnerable. The best way to fix this problem was to just carte blanche block the support of HTTP, and that forced all these end users to update their dependency or update their repository declarations in their builds to fix this. Absolutely, broken software everywhere. So what about everybody else? So these, Maven Central, JCenter, Spring, Gradle, Plugin Portal, those are the biggest artifact servers, right? But there's a lot of small independent artifact servers that are around the industry. How do you clean those ones up? Well, enter CodeQL. So I was able to write this. I wrote this short little CodeQL query to look for inside of POM elements, which, CodeQL runs So one of the things that CodeQL has built this website called, or the people behind CodeQL built this website called LGTM.com. On LGTM.com, they continuously have a list of projects that they look at, and they constantly ingest those repositories, build them, and build databases for them. And so if you have a project on open source, you can just, or if you are a security researcher, you can just say, hey, I'm curious about X project. And either if LGTM has built that project, or if they haven't, you can drop that project into LGTM.com, and they will attempt to build that for you and build a database for you. And so from that, you can take that and you can write CodeQL queries and run those against any of these projects that they have imported into LGTM. So I was curious about what places where this vulnerability still existed and was still leaving projects vulnerable. So I wrote this CodeQL query that looks for either that repository block. Unfortunately, this only supports Maven for looking at this. It does not support Gradle. But I was looking for repository blocks, snapshot repositories, or plugin repositories that are using HTTP or FTP. And if we go back a little bit, a long way, you'll see that this is what I was looking for. I'm looking for this repositories block with this use of HTTP here, here, or here, right? So that's what this CodeQL query is looking for. So yes. And so when it does, it alerts, it sends out this alert. And CodeQL, using this query, I was able to run this query against all of the projects that CodeQL or that LGTM.com has indexed, and get a list of vulnerable projects that were still vulnerable. And for this query, because of GitHub's bug bounty program, they have a bug bounty program around writing queries like this. I wrote this query, contributed it back to GitHub as a pull request, and for this query, they awarded me a $2,300 bounty. Since then, this was submitted back in 2020-ish. They've since increased their payout. So if I were to have submitted this now, it may have been paid out even higher. but that, you know, at the time it was still a significant amount of money, $2,300 for a very simple query and some documentation associated with it. And so now if you go to lgtm.com and you type in Maven in the search bar, you can see this CodeQL query and you can see the alerts for it. You can just page through, you know, pages and pages and pages of alerts about this vulnerability. So I had this, you know, alerts page with all these lists of vulnerabilities and who is still vulnerable to this. And I was like, okay, we know these projects are still vulnerable. We have a list of those projects that are still vulnerable. Let's go fix this, right? So let's do this thing. So I was like, okay, I can not just know that these are vulnerable, but like this is a relatively simple vulnerability. Let's just go generate pull requests. So yeah, they're open source. It's all, you know, it's all open source. I'm an open source contributor. Why not just automate me at scale? And so this is what the diff was looking like of what we were trying to generate, right? It's basically just looking for the use of HTTP in that repository block and replacing it with HTTPS. My first crack at this, I used regular expression. I don't advise this in the future, but you know, I managed to get a complicated enough regular expression for XML that I was able to get this to work. And the reason that the other reason that I did this was the GitHub Security Lab has they have two bug binding programs. They have all for one for all, which is you take a CodeQL query that you've written and contribute it back as a pull request. And they have the Bug Slayer program, which is you take a CodeQL query that you've written and you use it to find security vulnerabilities and get them fixed, reporting them to projects. So they had, you know, at the time it was 4 vulnerabilities fixed at, you know, upward at a cap of $2,500. And I figured because there were 17,000 projects that were vulnerable, you know, divide that by 4, multiply by $2,500. And you get, you know, $1 million. I figured it was a quick way to become a millionaire off of GitHub Security Lab. It didn't happen that way, but you know. Let's dive into how this bot works. And if anybody has any questions, I'm happy to dive into the code a little bit more. I have it up on my side. I'll do that afterwards. But this thing is built on top of the Hub CLI, which is GitHub wrote a CLI for GitHub called Hub, which is a wrapper over Git. And so it basically, a lot of my program just shells out to that. It's using PyGitHub, which is a GitHub. It's a Python wrapper over GitHub's API. It's using async IO, which means that I can run all this stuff asynchronously. And it's using, well, at least for the Maven fix, it's using one very annoying regular expression, and then a lot of bouncing off the rate limiting API that GitHub has. And this is the result. Thousands of pull requests. This screenshot was taken, a while ago, but lots of pull requests and a lot of closed pull requests as a result of it. We'll go into the numbers eventually, but for this work, for generating thousands of pull requests, or at least, I think at the time it was 1,596 pull requests, GitHub awarded me a $4,000 bounty for this fixing security vulnerabilities. They paid me. They were going to do 2,000, but because of the scale of the amount of vulnerabilities fixed with this one pull request generation, they doubled the payout to $4,000, which is spectacular.
Jonathan, real quick, there's a question in the chat. How do you actually do a PR at scale?
A PR at scale, I have this bot running on my local machine, and I check out everybody's code, make the modifications, right? So I have a bot that I know all the projects that are vulnerable, and I know all of the file names of all the files that are vulnerable from that CodeQL query. I then check out everybody's code, and then find that file with my scripts, go in, make the modification with the regular expression, or when I get to the JHipster case, working with Jonathan Schneider and OpenRewrite, sending that file to OpenRewrite's API to do the refactoring of that code, get it back, put it, replace the file, and then I run a git branch command. And then I use Hub to Well, first I have to fork the repository, and then I have to generate the pull request and then use Hub to submit the pull request. So all of that stuff, it's basically doing all the stuff that you would do as a regular open source contributor, but repeatedly and with a script in a repeatable way. So it's, but I'm doing that all locally from my machine. I'm not, doing anything special. GitHub does not offer any APIs specifically for doing this. I'm basically going through the process of any open source contributor, just doing it repeatedly at scale. Yeah, great question. Great question. Absolutely.
Yeah.
And the bot that I've written is modular enough to be able to plug in. I can basically take the problem of I have this project that I'm working on, and I can plug in the specifics for that project. And then there is an underlying engine that I've written that does all the bulk pull request generation, like automation, but it's modular enough that you can use it for, if you have other projects that you want to do this for, you can just plug in the specifics of how to rewrite the source code for this vulnerability, and it'll just, do the work, basically. But the underlying engine is agnostic of what problem you're trying to solve. That, answer the question for the most part?
Yeah. MedApp seems to be clear on that.
Cool. So let's talk about JHipster. JHipster, I found a vulnerability in JHipster, which is CVE 2019-16-303, which is the use of insecure random number generation in a security sensitive context. The reason, so let's just dive into that really quickly and what that means. When you are generating secrets, for example, let's take the if you've ever gone through the flow of I need to reset my password, you usually say, please reset my password, and you'll get an email back, right, that says, here, click this link to reset your password. That email link includes a random string at the end of it, which is a sequence of, random information for a URL for you to click on, and that'll send you to the reset page. What happens if that reset URL is predictable, right? If you're not using a secure source of randomness to generate those reset URLs, you can generate one and have it sent to your email, and then predictably compute what all future values of those reset URLs will be. And so you can reset anybody else's account on that platform and know what that reset URL will be, and then change their password without needing to be in their email, right? And so that's where how we solve this in software is you use what's called a CSPRNG, which is a cryptographically secure pseudo random number generator. Now, there are a lot of random number generators, and the Java has one. It has random and then secure random. Apache, one of the most common ways that you'll see this vulnerability is Apache Commons Lang 3 has an API called generate random string. And that is used to generate these reset URLs. However, Apache Commons Lang 3 random string utils, the random number generator underneath that is predictable. It's not a secure random number generator. It is a pseudo random number generator. And so if you have one of those resets URLs that is generated by that string, you can predict what all future ones will be. So I discovered this I was looking for random string utils Apache, because I know about this vulnerability. I know that random string utils is vulnerable in this way, or when used in this way, creates this vulnerability. So I was curious where I could find it. And I started finding this in a bunch of different places, but the one place that I started finding it a lot was I kept finding this same file called random util, and it had the same name, and I was finding it everywhere. And I was curious why. And what I tracked it down to is I finally tracked down that this class, this random util class, was being generated by this project called JHipster. And you can see this vulnerability because here's an example of that. Generate reset key. This is the reset. This is the generation of that reset URL for resetting your password, and it's using this predictably random function. So yeah, I was finding it, and so when you search for this, I found this in like 15,000 instances of this across GitHub. And unfortunately, GitHub has search limitations. The GitHub search only returns the first 1,000 results, even with pagination. And there's no way to slice the data with additional search parameters that I could find. So I was looking. I wanted to write a CodeQL query to find this vulnerability and fix it in as many places as I could, because the vulnerability had been fixed in JHipster, but there were still 15,000 projects with this vulnerability across open source that had been generated, and nobody was ever going to update. And I knew that a lot of these projects were one-off projects that nobody really cared about, but some of them could be projects that were important, that were actually being used in production. And so I wanted to make sure that even if I got a lot of projects that nobody was going to care about, I'd hopefully hit some projects that were actually being actively developed. So the search limitations, I can't, when I'm searching for this, I can only get the first 1,000 results, and there's no way to slice the data. So how do I get the full list of projects to then import into CodeQL and run a CodeQL search to make sure that I'm fixing specifically, like, these are the projects that actually have this vulnerability. I was able to reach out to Chris Gavin and Arthur Bars, and they, I had, with my connection to GitHub, and they thankfully were able to get me a list of 9,000 repositories. So I actually had to work collaboratively with GitHub internally to get this information, to get a list of 9,000 repositories that were vulnerable, or potentially vulnerable. From that 9,000 repositories, we took that 9,000 repositories and then imported all of them into LGTM.com. And then I just needed to write a CodeQL query to find specifically that vulnerability, to make sure that they were actually vulnerable and not just, fuzzily vulnerable because of the search, the CodeQL or the GitHub search that I'd written. So this is the CodeQL query that finds that vulnerability in JHipster, that JHipster vulnerability. So what we're looking for is a class called randomutil. So this is the I'm looking for a vulnerable JHipster random util method, right? And so what we're looking for is a class that is called randomutil, and it has methods that match the name of generate. The return types of those methods are type string, and the return statement of that body is a singleton. Basically, the statement has one statement, and that statement is a call to predictable Apache random string utils method access, and a call to a predictable Apache random string utils method is the methods. So this is looking for a method that's declaring type as Apache random string utils. And so Apache Commons Lang 3 random string utils has a bunch of methods on it, but there's only one that would make you not vulnerable to this, and it's a call to the method name random, because that method name random takes a random number generator as its argument, right? And so if you're calling that, you're probably calling it with a secure random number generator, and you've not used the version that was generated by by JHipster's vulnerable version. So, and then down here, I select all the vulnerable JHipster random methods and just state out, because I've found that you're using a weak random number generator in a security sensitive method, and then this is the JHipster CVE, and it just tells you that you are vulnerable to this. So this is the CodeQL query for finding that vulnerability. But this led me to the question of, okay, like, I have the CodeQL query, I can find the vulnerabilities, I know which projects are vulnerable. How do we rewrite the code? How do we, I first did this with a regular expression, but this is not going to work for source code, especially if it's formatted differently or something like that. How do I fix this in a way that preserves the overall syntax? And this is where rewrite comes in. It was developed by Jonathan Schneider while at Netflix, and the Rewrite project is a mass refactoring ecosystem for Java and other source code. And most importantly, it's format preserving, so that if you are using your own custom formatting, you can it will still rewrite your code in a way that preserves that. Jonathan's going to give an example of what rewrite is, not specific to the JHipster case, but just a general, like, this is what rewrite is and what it can do. So, Jonathan, you want to take it away from here? And
absolutely, yeah. Thanks, Jonathan. And I'd like to also just kind of connect, CodeQL is to LGTM, OpenRewrite is to Modern, and we'll talk about that in a little bit. But OpenRewrite is an abstract syntax tree based manipulation of source code. And OpenRewrite's abstract syntax tree is a little bit special. What it has is not just the syntax of the code, but also all the type information that the compiler infers, the formatting information of the original code, which the compiler wouldn't need normally, but we preserve that information in the AST. And then you do an AST manipulation, and when you print it back out to the code, what you get is the change that happened in the code, but preserving all the original style. So let's show a recipe actually around another security vulnerability around insecure creation of temp file directories. And for that, I'll just share whole screen, hopefully. And can you see my IDE? Hopefully.
Yes.
Okay, great. Yeah, so in many ways in OpenRewrite, a recipe, this unit of transformation we call a recipe. And a recipe is actually just a program. You'll notice that there's a lot of
Can you put yourself in presentation mode for the stream?
Sure.
Can you put your ID in presentation mode? Cool.
You notice there's a lot of surface level similarity between OpenRewrite and CodeQL. Insofar as it kind of looks like code here. In the case of OpenRewrite, it actually is just regular Java code, and we have the ability to write recipes in other languages as well. And the core part of a recipe is really what's called a visitor, and the visitor is the thing that does abstract syntax tree visiting and makes a change. So in the case of a, kind of scroll down here, in the case of a, actually, let's go to a test real quick. It's kind of easier to see what we're trying to replace. If you have this thing called like file.create temp file, that allows for, I suppose, and maybe Jonathan, you could describe it like hijacking of the original.
Yeah, so this is a vulnerability that I've been interested in, and I'm also planning on chasing down with another bulk pull request generation project with collaboration with Jonathan on this. This is what's called temp directory hijacking. And so what you'll see here is that you have a call to file.create temp file. The basis of this vulnerability is that on Unix-like systems, so Mac OS and Linux, the system temp directory is shared between all users. And so because of that, if you are writing sensitive information to the system temp directory without setting the correct file permissions, that information will be disclosed to other users on that system. And by users, I mean like local, like you have on a computer, you can have multiple different accounts, right? And so the temp directory being shared between all those accounts, the file permissions on that file mean that if you're writing to it or your application is writing to it, other files can read that information. Now, this is a little bit different than that. This is actually, the vulnerability here is that the Java process that is running is creating a temporary file, and the goal of the user code is to create a temporary directory. But before Java 1.7, Java did not have a standard library API for creating a temporary directory. And so what you're seeing here is a very common pattern you saw in Java code to create a temporary directory, because you wanted to create a temporary directory with a unique name. And so create temporary file created not just a temporary file, but it also created a temporary file with a unique name that was guaranteed not to conflict with an existing temporary file. But people then wanted a directory, so they would delete that file and then make a directory out of it. However, the problem with this is because the system temp directory is shared between all users, if you created that file and then you deleted it, another user on that system could watch for that, see that that file was created and then deleted, and then race a Java project to create that directory first with wider permissions. And if it beat it to create a directory before, if an attacker is able to create a directory before the Java process's makedir gets called, then the attacker is able to own that directory. And this is because temp directory.makedir doesn't throw an exception if the make directory fails, it returns false. And so because it returns false, it would silently fail, and then that directory would be hijacked and be able to be used by any other user. And so this is a bigger problem. There's an example of this vulnerability that I found in Jetty, which is a popular server implementation for Java. And if you had this chain of events, because most often in that temp directory, there was JSP pages, which are source code, were written into that directory. If an attacker can write their own code into that directory, when the JSP pages are loaded, you could get privilege escalation because you were writing a file that had code in it, and then the other user was then executing that code. And so you could then run code as that other user, which is privilege escalation. And you'll see that a lot of cases, temp directories are used to write out code, and this sort of vulnerability leads to temp directory hijacking. So this is the pattern that Jonathan and I are working together to try to fix across open source.
Great. So then back to the recipe, then you'll see that actually what we have, maybe it's just easier to start from the unit test, is OpenRewrite has a whole unit testing harness where you can actually write code that resembles what the before condition is and the after condition is. And a lot of work has gone into the tooling to make sure that the IDE even actually does completion hinting for you on writing these code samples. But rather than create temp file, we want to say files.create files, not file, files.create temp directory .to file at the end, and this is a more secure pattern. If we head back over to the actual visitor here, so what we're really going to do is we're going to visit method invocations. We're looking for that create temp file, and we can create these little method matchers like this. Like if it's a java.io.file create temp file with any arguments, then I know that this method invocation belongs to that. This is really kind of like a search behavior, kind of like what you see with CodeQL. And now I'm saying if there's two argument, a call, then I actually want to replace it with this snippet, files.create temp directory. And I'm going to use the two original parameters from the original call. And I'm going to build up an AST snippet here with this method invocation instead, and insert the old abstract syntax trees for these two parameters here in the new call. And then similarly, there's a 3-argument form that we can generate as well. So if we go to the test, you'll see, we're just able to run this and, actually, validate that this pattern in general works.
And just quickly, is this a more desirable outcome because you have assurance that the Java process is actually making the directory? Is that why you'd want to use this method over the previous insecure one?
So the reason it's more secure is because the version that you saw before, right, where you're writing out the delete and then the makedir, that's insecure. The new method, which is files.create temp directory, has a bunch of security guarantees that are implicitly provided by the Java standard library around that directory being created in such a way that the file permissions are set correctly, and that directory is so basically you're guaranteed that will not be hijacked by using that new method because they designed it to be safe in a security sensitive context.
So I want to give you a sense of what this actually looks like to run, en masse. Actually, the same recipe that we just saw there in the IDE actually exists here on app.modern.io, which in many ways is the equivalent to LGTM, but for OpenRewrite based recipes. And again, just like Jonathan explained about LGTM, this is a free for all open source projects, and we regularly go and batch ingest and try to build the code of any repository that's been input into the system. And if I take this recipe and run it, I can run it on 629 repositories in this case that are in the, and it's very, very fast. So we can go identify all places where that old file.create tempter was actually used. And if I go look at some examples here, not only have we identified the location, but OpenRewrite has actually fixed it here. And if I'm a contributor on this project, I can just say commit. So it's kind of like the next evolution beyond just identifying issues and instead actually remediating them. And similar to what we're seeing with Jonathan's bulk PR generator here, if I owned all 57 of these projects, I could commit all 57 of them simultaneously. So that's kind of the next sort of look. Back to one of the examples that we were talking about earlier, which was just, find method usages of that, Apache Commons lang random string utils, we could kind of do the same thing. Or maybe look for any method with, random star as the beginning. And there's, a similar way here. We could go identify these. And again, because the abstract syntax tree is type attributed, any actual method I find is guaranteed to be of that type. It's not a text-based search. It's an abstract syntax-based search with all that type information imbued in it. So I think this is kind of similar in capability. Searches in OpenRewrite are really just a matter of adding a marker to the AST, and then we render this marker in this way. It's really got a similar like discovery capability as CodeQL, but has that repairing functionality as well.
So does OpenRewrite have a ability, like I guess, how does it work in terms of rules of known weaknesses or defects in your code base? Is this like is that also open source, or how do you know?
Absolutely. Yeah. So every every recipe that we write or that we learn about is open sourced under the OpenRewrite org. So there's things for Spring and testing frameworks and Maven and Kubernetes and JHipster is, I think, the one that we were talking about here. Lots of different recipes. Those are always Apache licensed. And independently of the Modern platform, these recipes can be ran using build tool plugins on local repositories to just fix a repository on disk as well.
Cool.
Were you taking over, Jonathan?
Yeah, I can. Yeah. So it's like, from my perspective, it's super powerful and incredible. I actually hadn't seen the user interface and like kind of how far it's come until like last week, and I was like, oh my god, like just diffs of pull requests of security fixes, like it's just a serious fix. It's like knowing about the vulnerabilities is one thing, but being able to see like, okay, here are all the projects that are vulnerable and here are all the diffs. All that needs to be like kind of added is, great, go generate all the pull requests. Yep. And like you suddenly have the ability to just fix, massive widespread security vulnerabilities with a simple user interface, like the one that's being developed here. So it's really powerful technology that's going on here.
For us, it's been awesome. I mean, there was Adopt OpenJDK was retired recently in favor of Eclipse Temurin, and one of our developers came in and ran a recipe on all of our code. And we have about 60 repositories and just mass committed them all at once. And we have GitHub notifications like tied to Slack, and it was just like Aaron. It was just like, wow, somebody's busy this morning, but like actually just ran it and just was done with it. Right, yeah. Moved on to the next chore for the day. So I think that's a real interesting future, especially now that we have hundreds or thousands of repositories, just be able to commit.
Just for Oh, sorry, Jonathan. Just really quickly for people who are unfamiliar with abstract syntax tree, the benefit you get out of an abstract syntax tree kind of parsing versus regular just text parsing. What are the pros and cons there?
Yeah, I mean, it's the let's see, got a window over here. Text is really turned into a tree, which allows me to. Like John was saying earlier, he was trying to write a regular expression to replace URLs. That can be very difficult because, what if the value was on another line? So an abstract syntax tree allows you to kind of get to the relevant part of the code that you're trying to change. If I was wanting to change an if block, I don't have to try to write some sort of search to get there. And I'd say like a regular abstract, so you start with text, and a lot of abstract syntax trees are really just syntax. And what the compiler does, so this is the first phase of compilers, it builds a syntax tree. And then the second phase is it goes through and it kind of like solves for all the types that it sees throughout. So it knows, oh, this is an integer, and this assignment will be labeled with an integer, type attribution. This P would be, this method invocation would be type attributed as well. And then what ASTs typically lack is the white space. So how many spaces existed before M and before the if. And so what we've been taking is kind of the compiler internal AST with all the type information, then going back scooping all the white space out and comments and everything and stuffing those into AST as well. And what you get is this kind of rich stew at the end of just this like massive amount of data about the code. And that allows us to accurately identify P, not just any method named P, but a method named P with a particular receiver type. Now that type information is actually very deep because you could have like that particular method invocation, but what declaring type was it on? And what was its super type? And what was its super type? And what was the, and so what, if you kind of go all the way up that line, you get to do things like, you know, share another one here, which I just think is really interesting, is look for all deprecated usages of a method. So I could look at org.spring framework, for example. Any subtype there in package. And I could look for any method name and any number of arguments. And now a deprecation may be on the method call itself or the method declaration itself that's being called, or it could be on the super types method declaration, which was overridden by the type we're actually called. So, you know, you have to kind of like look all the way up the type hierarchy looking for these sort of things. And that's what's kind of there. So here we can say, I'm finding that this assert.notNull is actually deprecated in the Spring framework at the time that this code was called. And this has actually been helping us prioritize our action, what we build recipes for, to just kind of look for the most common issues that exist in production code.
Right. So you just get more precision, really. Like
That's
with
right.
an abstract syntax tree, it's just more precision than you would with a regular regex style. Yeah.
That's right. And some of these things, like suppose I was to look for a method called list.add, and I see a variable called L and I see .add. That L could be defined in the code, or it could be defined in the superclass, which actually could come from a binary dependency. It may not even be in the same repository. So, you know, lacking it, you know, no regex could ever identify that L as a list in that case. You'd have to,
right.
You really do have to look at the AST.
Totally.
We have a question in the chat by Sam asking if OpenRewrite supported only for Java, or if you have a roadmap for other languages. Malip does say that he thinks you can create recipe for other programming languages as well. So what's the story?
That's right. And so right now I'd say the disadvantage is it was Java focused at the beginning, but also support YAML, XML properties files, and we've been layering models on top of that. So Maven, Kubernetes, Circle CI, GitHub Actions, et cetera. So models are being layered on top of that. And one of the really exciting developments from the last couple of months has been that we found, and this is going to be controversial, but actually like there's like a Java family of languages, TypeScript, Python, Java, like .NET actually basically share the same AST model. It's just the act of taking the compiler internal AST and mapping it to that. That's the work to support a new language like that. And then a lot of the recipes that we've written, especially around stylistic consistency that were written for Java, actually work automatically on TypeScript or on .NET or Python and so forth. So there's a lot of lift that we gain doing that. And then, of course, other JVM family languages as well. Groovy supported now. Kotlin will be added. And that's the task ahead of us, is actually just, you know, broadening language support. And I would say definitely like CodeQL has much more language coverage at the moment.
And we have also a question from Ray. He's asking, did you initially consider a tool such as Semgrep? So I guess for Jonathan, okay, yeah, go ahead.
Yeah, so Semgrep, I mean, fundamentally, you know, these are search tools, right? But, you know, and that's the distinction, the main distinction I would draw is like search is great, but, you know, some of the customers we work have 250, 300 million lines of code. It's just not that actionable to say, you know, great, here's 100,000 places you got to go chase down and replace by hand. And I think that's the change that we need to see in the world. Those tools like Semgrep are going to be very difficult to turn into an auto-remediating solution just because of the way that they're built initially.
Yeah,
I
think they do have a functionality to remediate, but maybe not as much as OpenRewrite. And maybe on static analysis, Jonathan L, why
CodeQL
instead of another static analysis tool?
So the reason I was attracted to CodeQL, and I don't know what I actually should have done more research on Semgrep. I actually haven't. But the things that I experienced with CodeQL is that there was the LGTM.com. That website gave me that if you go to LGTM.com, you can very quickly, as soon as you like log into an account, you have a query console button you can click. And you can start writing CodeQL queries live on the website and running them against open source projects, right? The barrier to entry, you don't have to set up any tooling. You don't have you can just start writing things in your IDE, and it gives you, hints, type suggestions, all that stuff. And because of all that, right, like it's a very low barrier to entry, and then you can find these widespread security vulnerabilities. It also, CodeQL, again, I can't speak to Semgrep and what it supports fully, but CodeQL has features and functionality around data flow analysis. And so one of the examples of, data flow analysis is, let's say you have user supplied input. So if you're working in Spring, or you're working in, any of those, and they have the way that you declare in Spring that you have a user input is you declare a method, you annotate it with like get mapping or put mapping or whatever, and then you say it takes these parameters, right? And that parameter to those methods will be mapped from the GET request that is made by a user, right? But those strings that are coming into your application are potential inputs of user information, and they could be tainted, right? And so then CodeQL can do this really complicated but really powerful data flow analysis, where it can track that data as it flows through your application, and then see that information is that bit of information, that string, is flowing to, for example, where a string is getting concatenated together, and that's taint tracking. And if that string that's getting concatenated together is, for example, an SQL statement, right? And that larger tainted string is then flowing to an SQL call, right? You then have SQL injection, right? And not only can CodeQL detect that, but it can show you the 30 some odd steps that shows you, right? And so if you go to lgtm.com and you search for SQL injection in their search bar at the top, you can see query results, and then you go SQL injection, you go, I could pull this up actually. If you can I need to screen share another screen. But
yeah, go ahead.
Oh no, this is live. Okay. LGTM.com. And then if I go here and I SQL, and I can go to Java because I'm familiar with Java, I'm going to go with Java.
Could you make your font a lot bigger, please?
Yes, I can. So here, this is what you're going to see but you can go to the alerts tab, and you can just, I think that some of these are not SQL, but okay, yeah, you can see execute query, get SQL query by table.getName, and this is might not naturalize. No, sorry, this is not security. SQL SQL query built from user supplied sources. Here we go. So this is alerts, and I can go show path. Yeah, here we go. Okay, so this is show path, and so it'll show you the steps that result in this being a vulnerability, right? So these are it's not just showing you this is the vulnerability, but okay, down here, this is the call, a connection.prepare statement SQL, right? But this SQL statement is the result of a large, long chain of call. I actually don't know where that jump's coming from. Usually this is better. Let's see if I can find another better example. Query.toString. Okay, toString. Here we go. So this, this is in a toString method. This is why. Okay, I understand. Yeah. So this is part of a toString method. It's appending this query, or creating this query, and then preparing this, okay, the query is a string. I understand. So it's preparing the statement, and then calling it, and you can see that it's the full path of this call and where it comes from user supplied input, which is coming from this request.parameters.s column, right? So it gives you this full path, and you can also see not only this step, but here are 3 other examples of the data flow through this application that provide this information. And so this is super powerful for this is super powerful. And I can't speak to Semgrep because I haven't done the digging, but like that information is immediately available to you as a security researcher is incredibly powerful. And also you can just send that as a report off to a maintainer and say, here's the path of where your vulnerability is. You're clearly not sanitizing your inputs. And that, the information's right there, which is really, really useful. I have more slides, but if you want to, I'm also happy to answer more questions too. Either way. Nancy, you're muted, I think.
Yeah, the chat is pretty quiet. So if you want to proceed with.
Yeah.
Go ahead.
So, so for the going back to the JHipster case, this is what we rewrote the code to using the rewrite rule that Jonathan wrote. Anytime we saw this code, we rewrote the code to replace it with this bit of code, and you can see that now we're calling random string utils random with all these other arguments, but with a secure random number generator, and that makes this secure, right? Results. This number, I couldn't get an updated number. I was running something that was scraping the API. This is, I wrote this slide deck probably a year ago. So this was back a year ago. This is probably higher now. I did just update these numbers. So these are as of like the last week or the last couple of days. So for the JVM ecosystem's use of HTTP, when I've generated 1,596 pull requests. There are still 912 pull requests still open, but 460 have been merged and 186 have been, 184 have been closed. And so about 40% of those pull requests that I automated the generation for have been resolved. When I say closed, most of the time they get most pull requests when they get closed, they get closed, but they get merged by the maintainer because they want to do their own merging process. So that's why I include closed as like resolved. For JHipster, I generated 3,880 pull requests and 56 have been merged. That number is probably higher. I have seen more. It's probably about 80 pull requests merged at this point, maybe higher than that, but still relatively low. I presume that's mostly to do with JHipster is in a lot of cases used to generate one-off projects that are, like as somebody trying out the platform or going through a workshop or something like that, and they've just checked, they've uploaded their code to a project. But hopefully some of these projects were actually like valid applications that were live in the wild. And so I still consider it a win, even though the numbers of merged are still so low. And I plan to do more of this with other projects. So there's some lessons that I learned from this. First off, sign off all the generated commits. This will significantly increase the likelihood that your pull requests are accepted. So this is the -- sign off on the bottom of your commit. So I've added that as a by default thing when I generate these commits, because a lot of these organizations, when you're doing bulk pull request generation, they require an SLA to be signed. And so I can't sign 3,000 SLAs, right? And so just signing off the commit and then saying, hey, I'm not going to sign your SLA. If you consider a sign off of the commit enough, great, go ahead and merge it. Otherwise, feel free to close it and fix it yourself. But, it's just a scale problem. Have some fun, live stream it. So when I do these bulk pull request generation, I live stream this whole thing, and it's a lot of fun.
Late at night.
Yeah, late at night. Yeah. Oh yeah, very late at night. Yeah, Jonathan's been in some of these things. So my bot broke a lot. And so I was basically debugging it live. And so saving the state of knowing how many pull requests I generated and then stopping and then being able to pick up again from where I'd already started was really useful. So I could fix the thing as I was running it. I would love to make this thing, given it's actually gotten a heck of a lot more stable since I've generated like these thousands of pull requests. I'd love to make it so this thing runs as a service. So it's running continuously, monitoring for new alerts, and just like generating pull requests whenever a new alert is identified or a new security vulnerability is identified. That's going to be one of the projects that I'd like to take on across the next year of my Dan Kaminsky fellowship. It's just automatically generating these pull requests, just listening to alerts being generated. There exists a Mac write per second API limit. GitHub, GitHub is this very hidden bit of documentation somewhere, if you're making a large number of post, patch, put, or delete requests for a single user or client ID, wait at least 1 second between each request. This is the thing that slows down my pull request generator the most, because I have to slow. I like the code can run faster, but GitHub's API doesn't want me to run that fast. So I have to rate limit myself in code. It's a real pain. But this,
and there's multiple calls per PR too, right?
Oh yeah, absolutely. There is the fork the repository, and then so forking the repository and then generating the pull request, and it's 2 requests, and then the pulling is thankfully a GET request. It's not an API request. So yeah, you run into these things very quickly though. I ran headlong into the kernel task on macOS exists as a software hack to keep the CPU from overheating. I had the kernel task using 5,000% of my CPU to prevent it catching fire. This is when I was live streaming and doing the bulk pull request generation at the same time. So I have a better computer now, but the thing got hot. So yeah, don't fork 1.5 thousand projects against your personal account.
We lost your sound, Jonathan, I think.
Oh, can you hear me now?
Yeah, I can hear.
Okay. Don't fork 1,500 projects against your personal account. I did that, and my account became the angry unicorn. So if you went to you went to github.com/jlightshoe, it would not load because until you refreshed it like 3 times because it took so long to load my page. So GitHub has implemented some fixes for this. It's better now, but I definitely became a stress test example of my repository. I did have to throw ice underneath my laptop. I have a newer laptop now, but this thing got hot. So forking thousands of repos with Hub will cause name collisions. So you can, if you're generating thousands of pull requests, there's a high likelihood that those repository names, some of those will have the same name, and you can't fork a repository if you already have a fork of a repository with that same name. And so solution is to rename the repository after you create it to something else. Or because this requires a second write operation for every repository, you don't do that. And you just create 35 GitHub organizations, and you fork under those 35 GitHub organizations. So I currently own 35 GitHub organizations, each with a different number at the end of them, and then fork to those repositories subsequently to solve this problem. And so I have a lot of that's how I solve this problem instead of rewriting the name. Also, do not click enable all for dependabot alerts on these, because then you'll end up with your notification feed trashed. And I would not do this with my personal account if you want to use it functionally. I have a lot of connection with the GitHub team. But if you're going to do this yourself, and you don't want to trash your GitHub profile and make it so that it sometimes doesn't load, I don't suggest doing this against your personal account. Use like a bot account that you create for GitHub. So that's this talk at a high level. I'm open to any questions, and happy to dive into code or anything. There's the bulk pull request generation project. The other thing that I need to talk about really quickly is LGTM.com. So how am I able to run these CodeQL queries against thousands and thousands of projects across CodeQL? The way that I'm able to do this is there is under your account, you have these things you have a project list tab right here. So up in the top left corner, project lists. And this project list, you can, when this thing loads, and it loads, because I have 2,400 projects in my account, it takes a while to load, but you can follow a project. This API requires that you add each project individually one by one, right? Unfortunately, that takes forever, especially if you're trying to import into your account an entire organization. For example, like I want to import all of Google's projects into my account, right? Every project that Google has. So I actually wrote another set of Python scripts to use the API that this endpoint uses but with Python. So it's basically doing what the user would do, but with using internal APIs on the site. And so that's another account. If you go to my LGTM hack scripts. So this is another repository. It's called JLightShoe LGTM hack scripts. And that lets you do this bulk import of tons of projects into your LGTM account to run these CodeQL queries against thousands of projects to find these vulnerabilities. So yeah, that's the only other resource that is of use.
Cool. And I just threw a link to the docs for OpenRewrite. There was a question on how to get started in abstract syntax trees. I don't know if Jonathan S., you want to just add to that, or it's all in the docs.
Yeah, plenty there. Happy to chat on Slack as well, which is the links at the top of those docs.
Cool.
I'm also available on Twitter by Twitter DMs. There's also the GitHub secure. I'm also, the best place to find me is the GitHub Security Lab. Sorry, my screen's over here. My camera's here. Please forgive me. The GitHub Security Labs has a Slack channel. If you Google for GitHub Security Lab and then contribute, there should be a link to a Slack channel. And if you'd like to, you can either DM me on Twitter, or you can find me in the Slack channel there, and I'm happy to work with you. I'm looking for projects to collaborate on. If you know of any widespread security vulnerabilities that impact thousands of open source projects, I have a year of doing security research and looking for vulnerabilities and fixing them. And so I would love to collaborate with people on doing bulk pull request generation and fixing widespread security vulnerabilities and just generally cleaning up the ecosystem to find, to do good and see if we can, make the ecosystem and the open source a little bit more secure.
So we added a link to the workspace in the chat, and you'll probably find them in the show notes as well. So if you want to contact Jonathan and work with him on that. What else? A lot of great comments of, this was great. One tall girl 78 saying that she's going to try some of these. I had a question regarding the type of vulnerabilities that you can fix through this. Is it anything that you find is a good process for all those pull requests? Let's say like Log4j that we had to deal with during the holidays. Is that something that you could have gone and fixed for everyone?
So I think that Log4j is a case where, Dependabot is a better case for that. So Dependabot is a tool that GitHub was developed by Gray Barker, and it was bought by GitHub. And Dependabot is this tool that lets you automate updating your dependencies. It doesn't work necessarily for Gradle. Unfortunately, I did work on that problem. It's not a solved problem, but I have worked on trying to solve that problem when I was working for Gradle. But in general, Dependabot, and then there's also Renovate is another tool that is tailored to trying to fix updating dependencies, and those are really good candidates for those sorts of problems. Less so this thing, but yeah, the cases where this bot is most useful is cases where the code snippet is small. Jonathan, maybe you can speak to this in the future, but currently OpenRewrite is not necessarily the best at handling data flow analysis or taint tracking sort of based vulnerabilities, because knowing which variables may or may not be tainted is a more difficult problem. But in general, for example, all of for the temp directory one, right? All of the things that are involved in that vulnerability can be isolated to a set of calls that are repeatable and you see in a lot of places, right? Yeah. And so those are great candidates for these things. I would love to take on potentially trying to solve SQL injection across the Java ecosystem, but that's a big problem to try to solve.
It's not as big as you think. And I think taint tracking feels very magical, but it's actually fairly straightforward. And we do need to add that feature. And I keep trying to nudge you to do that, Jonathan. But if you don't do it, I'll get around to it sooner or later. I would add one thing to Log4j, which is, and there's just so many practical difficulties you run into. And one of them that I know is impact a lot of enterprise customers is that older minor releases of Log4j are unmaintained and that we're not patched. So tools like Dependabot and so forth and Renovate don't help you in that case. Right? And so I think whenever we think about these, and even if they do, in an organization with tens of thousands of repositories, it feels overwhelming to commit to all of them. So, anything we can do, and this is CodeQL, this is OpenRewrite, this is Semgrep, all these tools that help to limit the actionability, like the scope of required action, are very valuable. Because in this case, I think it's not every logging statement, right? It's logging statements that involve user supplied input, concatenation, or parameterization ultimately. It's a difficult problem to go search for, but I think this is why, a lot of us are putting a ton of effort into making this more solvable.
Cool.
Yeah, I think we're good. We're a bit past the hour. That was great. I really enjoyed it. I learned a lot.
Yep.
Thank you, everyone. And like I said, everything will be every link or documentation we talked about will be in the show notes. So feel free to go and check that out. Contact information for Jonathan L at least will be there as well. And the GitHub Security Lab workspace where you can collaborate to as well. The link will be in there. So for next week, we have another show coming up with Farah Hawa on OAuth 2 hacking for beginners. So check that out. Check us on social media, meetup.com. Follow us if you're interested so you have your reminder on. Any last word, Nikki?
No, this was great. I think we all learned a lot. Thank you both for being on the show and walking us through this. It's really great to see people trying to solve problems at scale. I feel like we need a lot more of this in our industry. So hats off to you both for, trying to do the impossible here.
Yeah. So that's it. Thank you and see you next week.
Thanks.
Have a good week, everyone. Bye-bye.